Hello, everybody. Welcome. I'm going to go ahead and go through. We're starting Unit 7 today. So we're doing similarity and proportionality. So we're working on Lesson 7.2, similar polygons. So a similar polygon are figures and figures that are similar, have the same shape, but not necessarily the same size. So, and when we have notation for similarity, we use a little kind of squiggle. And that's not very good. That's better. So we use the notation for with a little squiggle, and that means similarity. So if we're looking at this first picture, we see two triangles here. And we would say that triangle 1 is similar. Oh, I am not writing well. Let me fix that. To triangle 2. So the proper notation for that would be triangle 1 is similar, using that little similarity symbol, to triangle 2. Okay, and we see that because these have the same general shape, but they're not the same size. Triangle 1 is definitely smaller than triangle 2. So while looking at the second picture, we can say that triangle 1 is not similar to triangle 3. And that's because triangle 1 and triangle 3 have a different shape, right? They're also a different size, but triangle 3 looks more like a right triangle. So they have a different shape, so therefore they're not similar. And so the way we would denote that is we would say triangle 1. We'd still do the similarity symbol, but we'd put a little like cross through it. So that means triangle 1 is not similar to triangle 3. Okay. So we have more than just this. We also have some theorems that go with this. So we can say that two polygons are similar if and only if their corresponding angles are congruent and corresponding sides are proportional. So if we're looking at this image, sorry, I have some stuff drawn there. If we're looking at this image, we have two figures here. And so in this diagram, we can say the polygon ABCD is similar to polygon WXYZ. So again, the similarity statement, the way that we would write that is we would say ABCD is similar to WXYZ. Again, this is considered a similarity statement. Okay. And so the corresponding angles are going to be congruent. So if we're looking at this, angle A corresponds with angle W. So we can say, okay, angle A would have to be congruent to angle W. Similarly, angle B corresponds with angle X. So angle B would have to be congruent to angle X. Again, angle C corresponds with angle Y. So angle C is congruent to angle Y. And finally, angle D is congruent to angle Z. And we can also see this in the image with these little arc marks that are denoting congruence. So that's what it means when it says all the angles need to be congruent, but all the corresponding sides need to be what we call proportional. So they don't need to be the same, but they need to be proportional, which means we need to be able to say, if we take the length of AB, that's that first side, this one right here, it should have the same ratio to WX as if we took the length of BC and put that proportional to XY. That should be the same as CD. proportional to zy or yz, which again should be the same as dA should be the same as WZ. So again, these proportions should be the same. So their ratios, their division should be the exact same. And if we think about this, you can pick any of these sides. I'm just going to pick the first one. So we would be saying this should be 15 over 5. So that means this has a ratio of 3 to 1, right? Because both of those are divisible by 5. So I divide them both by 5. And we call this number that we get out, we call this the scale factor. Okay, and so again, you can test this with other sides. You can look and you can say, okay, well, 12 divided by 4, that's 3 to 1. 21 divided by 7, that's 3 to 1. And 18 divided by 6, that's also 3 to 1. So in order for this to be a similar polygon, we have to have all the corresponding angles congruent, which we do. But instead of being congruent for those corresponding sides, they have to be proportional. So they have to have the same proportion. In this case, that is 3 to 1. So again, the scale factor, the definition of that is the ratio of the lengths of the corresponding sides of two similar polygons. So you can only really do it between two. You can't do it between more than that. But that is what the scale factor is. So let's work with some examples. So we're looking at this first one, and we want to figure out if the polygons are similar or not. So if they are similar, we want to write a similarity statement and give the scale factor. So if we're looking at the first one, we first need to decide, okay, are all angles congruent? So we're given that angle N is congruent to angle R, so that's good. We're also given that angle Q is congruent to angle S. And because of those two angles, we can also say, okay, well, angle P is going to have to be congruent to angle T. What would I be able to say that by? That would be by that third angles theorem. So it's been a minute since we've done that, but it does still exist. Oh, third angles theorem. And that theorem says that if we have two sets of congruent angles, then that means the third set has to also be congruent. So we have three sets of congruent sides. Now we need to see if all, or three sets of congruent angles. Now we need to see if all the sides are in the same proportion. So we should see that, okay, well, NQ would have to be proportional to RS. So that means 12.5 would have to be proportional to 10. We can simplify this a little bit to make it a little bit prettier, or you can make it uglier. Either way is fine. I'm going to go with trying to make it a little bit prettier. We can double both of these to get a pretty number, and that's going to give us, if we double the numerator, 25 over 20. And you can actually end up reducing those down as well, because both of those are divisible by 5. So this would be 5 over 4. So again, this is working with that first proportion of NQ over RS. Okay. So again, if you decided to do a decimal, this decimal would end up being 1.25. So then we also need to test the other sides. So we'd go ahead and we'd say, okay, I need to do this side now. So QP over ST. Okay, so that's going to be 11.5 over 9.2. Okay, so to multiply that bottom, we'd have to multiply by 5. And to simplify that numerator, we'd have to multiply by 2. So I'm just going to go ahead and multiply them both by 10 and see if we can then reduce from there. So when we do that, multiplying both the numerator and the denominator by 10, just to get a little bit easier of a ratio to work with, we would get 115 over 92. Okay, so now we want to see if we can reduce that down at all. And both of those are actually, I know it's kind of hard to see, but they are divisible by 23. So when we divide them both by 23, we will get, again, 5/4, or as a decimal, 1.25. Okay, so we have two sets of sides proportional. So then we need to check to see if that third side is also proportional. So we're checking to see if we can do NP over RT. So that one is 15/12. And both of those are divisible by 3. So that would give us 5/4, or again, 1.25. So again, we're getting all three angles congruent, all three sides proportional. So yes, they are. In our proportionality statement, we would say triangle NQP. And again, the naming matters. So we have to start with, if we started at N, we have to start with R in the second one. We have to go to S, and we have to go to T. So yes, these are similar, and the scale factor, which I'm going to abbreviate as SF, would be 5/4. Or I would also take 1.25. Okay. So going on to the next one, again, it's asking us if these are similar or not. So we have right angles here, which if we have 3 right angles, we're going to have a fourth in both images. So that again means that, okay, angle W is congruent to angle N, angle Z is congruent to angle Q, angle R is congruent to angle Y, and angle X is congruent to angle P. So all the angles are congruent, so we're good there. We now just need to check our sides. So we need to see that WZ is proportional to NQ. So that would be, and you can do it the other way. You can do NQ over WZ, that's fine. You just got to keep your order consistent between the two. So I'm going to do WZ to NQ. And so that would be 10/18. And both of those can reduce by 2. So it would be 5/9. Okay. And then this is a rectangle. So if this side is 9, this side is also 9. So I'm also going to check WX. Again, I want to keep the order consistent between the two figures to NP. And so that's going to be 4/9. These two are not the same thing, so no. And that would be because the sides aren't proportional. So the angles are congruent, but the sides are not proportional, so that's going to stop us from being able to go further there. Okay, moving on to the next one. It says, using similar figures, find the missing measure. So we have a polygon QMNP is similar to polygon URST. We want to find the values of X, Y, and Z. So again, we want to worry about naming. And if we're talking about side lengths, the first thing we have to find is that ratio, is that scale factor. So we want to find two sets of sides that already give us numbers so we can find the rest of the figure. So we see that we have MN here, and MN is the middle two letters. That's going to correspond with RS. Okay, so we also have the length of RS. So we can set up our scale factor, our SF, and so that's going to be MN, which is 18, over RS, which is 30. And we can, I'm going to actually write that. MN over RS. So 18/30. And both of those are actually divisible by, let's see, 3, but we can go further. They're both divisible by 6. So that's going to be 3/5. Okay. And we do want to reduce that so that we can get a little bit better scale factor so that I can make our life a little bit easier. And so then we can go ahead and we can set up the ratio for the other sides. So I'm going to start by finding X. So X is NP, and NP is going to correspond to ST. So ST. So again, we'll take our ratio 3/5, and that's going to be the same thing as taking NP over ST. So 3/5, NP is X, and ST is 25. So in order to solve for X, we would have to multiply both sides by 25. And when we do that, you can do that a couple of different ways. You can think 3 times 25, which would be 75, and then divided by 5. Or you could reduce it first. 25 divided by 5 is 5, and then 5 times 3. But anyway you spin it, you should be getting out that x equals 15. Okay, and so that's going to give us our value for x. And then we can go ahead and we can do the same thing for y. So again, we should see here, okay, y is tu. Tu is going to correspond with pq. So pq, so this side right here. So we would say, okay, again, that ratio is the smaller to the larger. So we do have to be careful there because this time we need our smaller to be 15. That's in the numerator. And our larger is actually y. You can also, I don't know if you guys remember this, but back to the beginning of the school year, we also did some cross multiplying, which we can do here to help us. So we can cross multiply and we can say, okay, 3 times y, so that's going to be 3y, is equal to 15 times 5, which is going to be 75. And then we can divide both sides by 3. And so we should get that y equals 25. Okay. And then lastly, it asks us to find z. So z is referring to this angle. So that's angle M. And again, we want to look at what angle does that correspond with. Well, angle M is corresponding with angle R. And we know what angle R is. Angle R is 115. So those are congruent. So we can say z is equal to 115. So angles, again, are congruent. Sides are proportional. And you do just need to be careful of, am I writing the smaller side or the longer side first? Okay, so going on to the next one, we again are given that two things are proportional, and it's asking us to find the values of x and y. So we want to set up our proportion first. So I'm going to look in the smaller figure, and I see that I have this length yw. Okay, so I want to figure out that scale factor. So I'm figuring out, okay, well, what does yw correspond with? It's corresponding with bc. And so, bc. Whoops. That's my b. I'm going to change this picture. I don't know why it says that. Give me 1 second, guys. Yeah, you're going to have to change this. Okay, so we're going to get rid of this. This shouldn't say this. Sorry about that. And instead, we're going to replace it. It should be a... Oh, that's too big. Sorry, guys. This one should be... Gosh, I'm making a mess now. A, C, D, F. Okay, so this should be A, C, D, F. So again, we are looking at what corresponds with WY. That's going to be CD. So that's going to be this side. So CD. So we'll say WY, which is 6, corresponds with 9. Both of those are divisible by 3, so this is going to reduce down to 2/3. So that's going to be our scale factor. So the next thing we want to find is X. And X is going to be proportional, which is the side FD, so this side right here. So that's going to be proportional to YZ. So we want to go ahead and set up that proportion. So again, that scale factor is 2/3. We'd set that equal to, again, we went smaller to larger. So the smaller figure needs to be on top. So that means YZ is going to need to be on top. And FD is going to need to be on the bottom. So we can say 2/3 is equal to YZ, which is 10, over FD, which is X. And again, we can cross multiply here. So 2 times X is going to be 2X. And 3 times 10 is going to be 30. And then we'll divide both sides by 2, and we should get that X equals 15. Okay. We again then do something similar to find Y. And so we are given this ZV. So we have, again, our ratio is 2/3. And that's going to be equal. ZV is the smaller figure, so ZV. And ZV is going to correspond with FA. So this side right here, so 12. I'm sorry, I'm going to erase that, FA. So then we can really set up our proportions. So we can say, okay, 2/3 is going to equal ZV, which is 3y minus 1, over FA, which is 12. This time it may not be the best idea to cross multiply. Instead, we can multiply just both sides by 12. Because if we cross multiply, we do need to worry about distributing out to that 3y minus 1. So I'm just going to multiply. So 12 times 2/3. 12 times 2 is going to be 24. Divided by 3 is going to be 8. So we'll get that 8 equals, and then on the other side, those will cancel. So 3y minus 1. So then we'll need to add 1 to both sides. So we'll get that 9 equals 3y, and then we'll divide both sides by 3. So we'll get that y equals 3. So we got y equals 3 and x equals 15. Okay. I'd like you guys to kind of try this one on your own. Okay, so again, we're trying to find x and y. So we need to set up our proportionality. So we see Jm here, and Jm is going to correspond with QT, which is, so Jm is 4 and Qt is 2. So this ratio is just going to be 2. Or you can put 2 over 1. Those are the same thing. So we can say it either way. I'm going to leave it as 2 over 1 for right now, but when I solve, I can change that. And we want to find the values of x and y. So it doesn't matter which one we start with. I'm going to start with ML. So again, we have a ratio of 2 over 1. And that's going to be equal to the larger figure, so ML. And ML corresponds with ST. So over ST. I am going to simplify that 2 over 1 is 2, just because it's going to make my life a little easier. And then I can say ML, which is 6x minus 3, over ST, which is 3. And then I can go ahead and solve. So I'd multiply both sides by 3. So I'd get that 6 equals 6x minus 3. Because again, that denominator is going to cancel. I'd add 3 to both sides. So I'd get that 9 equals 6x, and then divide both sides by 6. So I'm going to get that x as a fraction, and that's okay. 9 over 6 is going to reduce down to 3/2, or you can write it as 1.5. And then I do the same thing in order to find y. So again, we have this side, this JL, and JL is going to correspond with QS. Okay, so I can say JL, well, I was again say my ratio, 2 over 1. I'm going to change colors actually. So 2 over 1 is going to be equal to JL over SQ. So again, I'm running out of room a little. But again, I see that my ratio is 2, and that's going to be equal to JL, which is 3y minus 2, over SQ, which is 5. I would go ahead and multiply both sides by 5. So I'm going to get that 10 equals 3y minus 2. I'll add 2 to both sides to get that 12 equals 3y. And then divide by 3 to get that y equals 4. Okay. And so those would be my values for x and y. So again, we want that proportion to be the same between the figures. So in addition to this, we can also talk about perimeters. So the perimeter of similar polygon theorem. So if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. So if we're looking in this picture, we can say, okay, if this figure ABCD is similar to this figure JKLM, then we can say, if we take all of their sides and add it together, so if we take AB and add BC and add CD and add DA. Okay, if we take the perimeter that's adding all the sides together and divide that by the perimeter of the other one, so JK plus KL plus LM plus MJ. That would be equal to the ratio. So it would be equal to that scale factor. So it would be equal to AB over JK, or BC over KL, or CD over LM, or DA over MJ. So all of those ratios would still be the same. So we're going to put that into practice. So this says these two figures are similar. It wants us to find the value of X and then find the perimeter of gazebo A. So first thing we're going to do is we need to figure out what our scale factor is. So we are given this side AB, and AB is going to be proportional to FG. So this side, FG. So that's going to give us 10 over 15, which will reduce to 2 over 3, because both of those are divisible by 5. So we can then use that to find X. So we would say, again, that ratio, 2 over 3, is going to be equal to, we're going smaller, so that would be AE. And that's corresponding, AE is corresponding with FK. So we'd say that 2/3 equals AE, which is X, over FK, which is 18. So to solve this, we'd multiply both sides by 18. Again, you can cross multiply if you want, but you don't have to. So 18 divided by 3 would be 6 times 2. That's going to give us 12. Okay, so that gives us that missing side is 12. So we see in our picture that this side is congruent to this side. So that means that in our smaller figure in gazebo A, that means that those two sides would also need to be congruent. So that's 10. And we could do a ratio for all the individual sides, or we could make our life just a little bit easier. Because we know that the ratio of the perimeters is the same. So again, we have 2/3. Okay, and we're trying to find the perimeter of A. And so that's going to correspond to the perimeter of B. And we know what the perimeter of B is. We can add all these sides together and find the perimeter of B. So we can say that's going to correspond to 15 plus 9 plus 12 plus 15 plus 18. Okay, so you can find all of the sides individually, or because it just asked me to find the whole perimeter, I can just do the whole perimeter together. So I'm getting 2/3 equals, I'm going to call the perimeter of A Y, just to make it a little bit easier to solve. So that should be, let's see. So we do 30 plus 18 plus 12 plus 9, 69. So then we multiply both sides by that denominator. So 69 divided by 3 would be 23, and then times 2, you should get that y is equal to 46. And we are going to include units, it's going to be 46 meters. Okay. Alrighty. I'd like you guys to try this one on your own. All right, so again, we're going to start by finding the scale factor. So we are given in this smaller figure, we're given RS. And this says A, B, C, D, E to P, Q, R, S, T. So I am going to do that in the same order. So we know that RS is going to correspond with CD. So I'm going to put CD on top, which is 4, well, CD over RS, just to keep my order consistent. So CD is 4 over RS, which is 3. Okay. And then it asks us to find the scale factor, which we did. We got that it was 4/3 of ABCD to PQRST. So again, it's asking in that specific order. That's why ABCD went on the numerator and PQRST went on the denominator. So we do need to be careful when it's asking us for a specific order. I don't think it's done that before. Yeah, it was just asking kind of find the values of x and y. It didn't ask necessarily for the scale factor in the specific order. So here, if it did, we actually would have to, oh no, that is correct. Just kidding. Oh no, we would have to flip our scale factor on that one just to make sure that it's in the right order. So for future reference, please be careful of that. If it's asking you to find that scale factor individually, we want to make sure the right order is given. Okay, but down here, so it did ask us, so we got it in the correct order, and then it's asking us to find the perimeter of each polygon. So the other thing we're given here is we're given a lot of little congruent pieces. So we're given that, and this is meant to say 6. Sorry, it got cut off. So we're given that this side would also be 8, and that this side would also be 4, which also tells us that this side would also be 3 if we were looking at that smaller figure. So we can find the perimeter of the upper polygon because of all those little congruent pieces. So we can say the perimeter of A, B, C, D, E would be equal to 8 plus 8 plus 4 plus 6 plus 4. So just adding all of those sides together. So that's going to give us 30. Okay, so that gave us the perimeter of the upper polygon. And so our ratio is 4/3. And we know that the perimeter of the upper polygon is 30. We just found that. And so that's going to correspond with that perimeter of PQRST. Okay, and so again, you can cross multiply just for the sake of solving this problem to make it a little bit easier. I'm going to call that perimeter y. And so we would cross multiply. And so we'd say 4y is equal to 90. And then we would divide both sides by 4. So we'd get that y is equal to 45/2. Or if you wanted to write that as a fraction, 22.5. And so this would be the perimeter of PQRST.